Alright guys, example 20. You guys already did 21?
Yes, we want to watch the
Overachievers. Alright. So, example 20. Kept the electric field strength 0.2 meters to the right, 0.4 microcoulomb charge. Which way is the field pointing at this location? What is the force felt by a -2 microcoulomb charge placed at this location? So, this one is asking you to kind of sift through a little bit more information to try to figure out what's going on. Alright? So we have two charges. We have 4 microcoulombs. And we have -2 microcoulombs. Right? And we have a radius or a distance which is 0.2 meters. Okay? Now there's a couple things that we need to figure out. Alright? Oh, wrong button.
That was 0.02 meters.
The 0.02?
I don't know.
Is 20 or 21?
20.
20. Okay.
Wait, is this number 20?
Yeah.
I thought we were doing 21.
No, 20.
Oh, oops.
No, it's 0.2 meters. Okay, so, couple things. We need to figure out the electric field at this location, and we have to figure out a force. Right? Now, I didn't label my cues because this is probably the difficult part. You guys got to tell me which one is the charge creating the field, and which one is the charge experiencing the field. So, which one's the big Q?
4.
Okay, good. The 4 microcoulomb charge. Just this big Q. Okay? And which one's the charge feeling the field? -2. Okay. So, our charge creating the field is the 4 microcoulomb charge. So, what does the field look like around this 4 microcoulomb charge?
Pointing out.
It goes out, right? Because it's positive, the field lines point out. Does that make sense?
Yeah.
So when I bring this little cube 0.2 meters away, right, it's experiencing that field. Does that make sense? Okay. So the first part was we need to figure out the strength of that field. Now we have two equations. So those are our two equations, right? E equals kq over r squared and E equals f over q. So which equation works for creating, which equation is the one for the field created versus the field experienced? Okay. The top one is for the field created because the big Q makes the field, right? Right? So we can figure out what the electric field is. So E equals 9 times 10 to the 9th times 4 times 10 to the -6 because that's what micro means. All over 0.2 squared. So you can figure out our electric field, right? So 9E, oh that's comma, times 4E -6 divided by 0.2 squared. What'd you get, none? What'd you get? 900,000? Well, I got 9 times 10 to the 5th newtons per coulomb.
Whatever.
Is that 900,000? Yeah, it's 900,000.
Okay. Make us put it in that form.
I don't care. I was just making you think. Okay. All right. Any questions? Any questions?
No.
Okay. Now we want the force felt by Q, right? Now this little q, is it positive or negative?
Negative.
Negative. So which way is little q going to feel the force? To the right or to the left?
Right.
To the right. Because the electric field lines point in the direction of a force felt by a positive charge. So if little q is negative, it's going to feel a force in the opposite direction. That can prove to you mathematically by using the second equation. E equals F over Q. E is 9 times 10 to the 5th. F, we're trying to find. Now which Q do I use, 4 or -2? -2. 4 created the field, -2 is experiencing it. Okay? So this is -2 times 10 to the -6. So now to solve, we multiply 9 times 10 to the 5th by -2 times 10 to the -6. And we get 1.8 negative newtons.
Yeah.
And since that 1.8, guys, since that 1.8 is negative, that negative does not mean left, it does not mean right, it means towards the
Other thing.
towards the center, towards the other charge, right? So that force is towards the other charge, because it's negative, right? And it also shows us since E was positive and F was negative, that they're going in opposite directions. Alright? Any questions?